So let's practice this in an example. Solve a triangle ABC if angle A is 42.3 degrees, B is 12.9, C is 15.4. So I tried to draw this as close to scale as possible. And again, I'm not sure if this angle C here is less than 90 degrees. I'm not quite sure. So what we have to do is we have to find side A first in order to use the law of sines. So I can have A over the sine of 42.3. So this is a perfect law of cosine setup. Side, angle, side. So A squared, that's what we're looking for. We'll use the first formula, equals B squared plus C squared minus 2BC times cosine of A. Let's substitute in our values. B is 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cos. Holy moly, I see myself using this over and over again. And on top of that, we then have to take the square root of that. I would not type this all in. For one, I think it's going to fall off my screen, and then I got to check to see if I typed it in all right. My philosophy is we're using a lot of calculator work here. Use your calculator, especially when you start getting big numbers in terms of decimal place values to type in. So here's what I would do in my calculator. I would take side B, 12.9, and store it in alpha B. Remember, the store button is above the on button on your calculator. Take the 15.4, store it into alpha C. A, B, C are right below your alpha button. And then I'm going to come back up here and type this in, the square root of B squared plus C squared minus 2 times B times C cosine, and I'll put in the 42.3, as you can see here. And then I'm going to store that answer for A. That will be my side A. So just in case I have to use it again. Oh wait, I'll have to with the law of sines. So this is approximately 10.5. Now, when I do my work on the tests or things like that, I like to use the stored value because now I have a rounding error. I've rounded this up, and that could affect my answer. In Pearson, where we have our homework, they will actually use the 10.5. So when you set up your law of sines, go ahead and use this answer. If you want, you can also use the value A that you stored, which is the 10.47376596. I'll have both answers on my answer key for the test. So let's solve this. So cross multiply the two you can, divide by the third, that's my sine of B. And then since we're looking for angle B, let's just go ahead and take the inverse sine of all this right away. So this way we only have to enter it once into your calculator. And again, if you wanted to, you could go inverse sine of B times the sine of 42.3 divided by alpha A. So there's my calculator entry. I use the numbers because that's probably what Pearson usually does. And we come up with 55.77. So we'll round this to the nearest tenths place, 55.8 degrees. So there is angle B. And again, once you have angle B done, then you might as well go find angle C by subtracting these two answers from 180. So 180 degrees minus 42.3 minus 55.8, 81.9 degrees. So now we've solved this triangle. Next example. A surveyor wishes to find the distance between two inaccessible points. Point A and point B are on opposite sides of the lake. While standing at point C, she finds that B is 259 meters, A is 423 meters, and the angle that is formed when taking those measurements is 132 degrees 40 minutes. So therefore, if we want to find this distance between A and B, you have a side angle side relationship. That is the law of cosines. So here we need c squared equals a squared plus b squared minus 2ab cosine of angle C. Plug in all of our information, and then take the square root of that substitution. Again, I would highly recommend storing values because you're using them twice. It's a lot of button pushing, greater chance for making a typo error. Rather see everybody type it in once and reuse it using alpha A's and alpha B's. And that way it really matches your formula. Here I typed in the angle for alpha C because we're just looking for one side. We're not looking for any other angles. So I've decided to use A, B, and C. 132 degrees plus 40 divided by 60 changes that 40 minutes into a decimal degree. And put in the square root of a squared plus b squared minus 2ab cosine C. We have 628.1 meters. All right. Again, just as a reminder, these are the two shorter sides. They have to add up and be bigger than this answer. So if we did a quick addition in there between our ears, we have 682 meters. So if you would have had an answer bigger than 682 meters, we would not have a triangle. Something went wrong. So 628 is less than 682, so all is good. All right, so if we're given a side, you must use the law of cosines to solve for an angle. It is helpful to rewrite the law solved for the angle first. So, like I said, this is my favorite law of cosines. Now, there's a couple different ways that we can work this out, and I'm going to show you one technique, then I'm going to show you my technique, and you use whatever works best for you. But almost every author is going to solve and get cosine C by itself. So to get cosine C by itself to solve for angle C, you have to subtract over a squared and b squared. All for it. Completely agree. Then we got to get cosine C by itself, so we have to get rid of the multiplication of negative 2ab. So I divide by negative 2ab. Now here's where I differ. Since most of the time your mistakes are made because of signs, a lot of authors say, well, let's take the negative on the 2 and divide it into everything on the top, which changes the signs. I'm not for that. Whether I leave the negative 2ab in the bottom or not, you will still get the same answer. So I prefer not to remove the negative. I leave it there because I'm letting the calculator do all the work. So some authors will call this an alternative form for solving for an angle. Well, you really haven't solved for the angle. You solved for cosine C. We really haven't found C yet. So some authors will now say, okay, you got to take the inverse of cosine of all those fractions. Again, to be honest with you, I don't have any of these memorized. This is the only one I memorize. All I have to do is 3 things. Subtract over the a squared and b squared. Divide over the negative 2ab, and take the inverse cosine of this fraction right here. Again, whether or not you change the sign still gives you the same angle. And I'll demonstrate both techniques that if you want to keep those and just copy them out of your notes, so be it. So, example. Here we have a triangle where A is 9.47, B is 15.9, C is 21. The first thing I do whenever I see 3 sides given, find the 2 smallest ones and add them together. Okay, what do we got here? 9 plus 15 is 24. 24 is bigger than 21.1. Okay, we're good. The two smaller sides add up to be greater than the largest side. So we do have a triangle. So I draw it out as close to scale as possible, if you will. Make sure 9.47 is the shortest side. 21.1 is the longest side. Because what we want to do is realize, hey, angle C has the opportunity to be an obtuse angle. This is the angle you have to find first. Law of sines only returns acute angles. Inverse cosine can also return an obtuse angle. If you want to double check with your calculator right now, take the second cosine of negative 0.5. It should give you 120 degrees. That's an obtuse angle. So always use the law of cosine with the largest side first to find the angle opposite the largest side. That's the key. So if you want to copy and paste one of that formula from the other side, here we're looking for angle C, inverse cosine of a squared plus b squared minus c squared all over 2ab. That's fine if you want to have it, write it down so you can reference it, power to you. Put in the numbers and go to the calculator. Again, store the numbers in A. In all seriousness, that's 1, 2, 3, 4 button pushing for just one number. Once you enter it in alpha A, it's just alpha A, 2 button pushings. No accidentally hitting the wrong button. So I put in my A, my B, my C, and then here's my formula. Then I just go second cosine, and I type exactly what my formula says. And I get my angle of 109.94 degrees. So yes, we do have an obtuse angle. Now, once you have this angle, you could use the law of sines to find A or B. And a lot of instructors and authors do that. But I'm all about efficiency. If I want to find angle B, and I look at its inverse cosine formula, I notice that all I did was switch the B and the C's around. Here's plus B squared minus C squared. Okay, plus C squared minus B squared. Here was 2AB. Take out the B, put in a C. These three are the only things I have to adjust. So what I do in my calculator, and since I have A, B, and C already entered, I just take my calculator, up arrow, highlight this statement, then go back and edit, change that B to that C, change the C squared to B squared, change that B squared to the C squared, and hit enter. 45.10 degrees. And once you have two angles, subtract them from 180. Angle A is 24.96 degrees. And you're done. Don't get me wrong. You'll probably watch videos or see examples. They'll do the law of sines to find another angle. But folks, if you got this statement already entered in your calculator, you just have to change 3 variable locations. And then you got another angle B. It's short, sweet, and easy. So that's what I like to do. I like to be efficient as much as possible. I know your time is valuable. All right, example 4. Find angle B to the nearest degree for the truss shown in the figure. All right, we have a side, side, side. Now here, these are just single-digit values and a 2-digit. This time, I'm going to do this without storing the values because the numbers are rather short. And again, I'm going to say, all right, I don't have those alternative formulas to solve for the angles memorized. So just start with your formula for the law of cosines. We're looking for angle B, so B is in the cosine. That means B squared is over here. A squared plus C squared minus 2AC. A squared, C squared on the same side. Same thing here, multiplied by 2. Enter in all the numbers except we don't know angle B. And what I would do here is now solve for B. So same thing we did 2 slides ago, solving for the angle. I'm going to subtract over 11 squared and subtract over 9 squared. Then I'm going to divide over -2 times 11 times 9. Notice I'm not doing any number crunching because who's going to take care of that for me? That's right, your calculator. Then we're going to take the inverse cosine of this fraction and go to the calculator and enter it. Now, I get it. If the numbers are small enough and you want to do some simplifying, if you want to call the 6 squared 36 or the 9 squared 81 or the 11 times 9, you want to call that 99, hey, so be it. Calculator gives me an answer of 33.03, and that's 33 degrees. I forgot that we were rounding to the nearest degree, so we'll just kind of ignore that 0.03. We'll call it 33 degrees. Now, again, don't get me wrong. If you want to use the formulas like we did previously, store all the values and type it in that way, you still get the same answer. Nothing wrong with doing that. All for it. But again, I'm not going to attempt to memorize this. I can get it right here from my law of cosines.